We are now looking at question number 33 from January 2017. This is a 4-pointer question that I dream of because there's so many free points to get on this. Every student should get at least 2 free points on this question. So let's see. All we got to do is you see question 33, graph f of x equals absolute value of x and g of x equals negative x squared plus 6. These are the 2 points right here that you get for free. Graph this and graph that and you're done. Like, that's 2 points right there. That's worth a whole multiple choice question. Then it asks, does f of negative 2 equal g of negative 2? It's a little confusing, but actually really not that bad if you understand what they're asking for. And then you just got to use your graph to explain why or why not. So let's get going. Let's graph this thing. First thing you'll notice is I do not have a set of axes. I'm going to have to draw in my own axes, and that's fine. Before I go and do that, though, let's get these graphed on the calculator to see if I need to draw it to the right or to the left or whatever, up or down, how far I need to go. So let's start by just graphing these 2 bad boys. Control page, I'll make a new document, add a graph, and I'm going to start by graphing f of x equals the absolute value of x. I already have f of x. Absolute value you find by pressing that button right next to the book. And then I'll zoom in a little bit on the calculator now so we can get this graphing going. Focus. There it is. Once you press that button next to the book, you should get this over here. And our absolute value is right over there. We'll hit X, hit enter, and it graphs it for us. That fits very nicely right in the middle of a 10 by 6 graph. So that's looking pretty good. Next, let's graph g of x equals negative x squared plus 6. So to do that, I'm going to press the tab button, right? The tab button right over here to get my next graph. I know it says g of x, but it's just f2 of x. It doesn't really matter, so I'm just going to start plugging in the equation they gave me. Negative x squared plus 6. We graph that. And nice, cool little pattern going on there. And it looks like I'll be able to fit this in a regular graph. So I'm going to try to fit my axes as close to the middle as I can over here as I'm going to go about graphing this now. Let's refocus. And I'll just do my best to put the axes right in the middle of the page. Right, I don't have a ruler, so I'm just going to try it freehand. You want your axes to be really thick anyways so that it's easy to see and you don't lose anywhere, so you can just color it in. That's fine. It doesn't need to look beautiful, right? This is an art class. Right around there. I don't know. Maybe that one looks better. Right over there. That's my x-axis. I think that was a little high. Whatever. It's okay. And now I got to start plotting my points. I will hit menu 263 to give me the grid, which is pretty good. If I want to use a table, I could always hit Control T and just start getting the points. This would be for the blue one. You see it's blue up there. These would be the Y values for my red one, matching with the X's over there. But I'm just going to, I got a nice graph over here. I'm just going to look at it and start graphing it. So, I have a 2-color pen. I can do it in the right colors. On your test, don't do it in 2 colors. Only black or blue pen. Or, yeah, I'm pretty sure. But I'm going to do it in blue. I've got the point 0, 0 right here. That's that one right there. I see on my graph, maybe it's hard for you to see from this far away, but I see the point 1, 1. So I'll plot the point 1, 1. The point 2, 2. Oh, this is a very nice one, right? It's your plain old absolute value function. So that's going all the way up there like that. Plot all those points. And then this one's going to be negative 1, 1, negative 2, 2, going up forever that way, right? So I'll just go ahead and plot all those points. I don't have a ruler, so I want to have the points. I can make it look nice. And I will do my best to make a straight line. And this is absolute value. It goes on forever, so I'll put an arrow there. And it goes towards the negative infinity as well forever. So I'll go that way. Put an arrow there. That's beautiful. I mean, it could be a little less wobbly, but that's fine. And now I'll do my quadratic function. I see my vertex hanging out over here around, let's see, that is 1, 2, 3, 4, 5, 6. That's the point 0, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Yeah. 1, 2, 3, 4, 5, 6. Yep, got it right. Next point that I see is 1, 5. 1 to the right and 1 down. So 1, 5. 1, 2, 3, 4, 5. And a nice thing about a quadratic is whatever I do on the right side, I can just match on the left side because it's symmetrical. Next point that I see is at 2, 2, 2, 2. So I'm going to go to 1, 2, 1, 2. Here's the point 2, 2. I'll put the matching one, just go to the opposite side like a mirror. 3, 1, 2, 3, 1, 2. Ooh, where does that go? That goes pretty far down. 1, 2, 3, 1, 2, 3. 3, negative 3. Let me make sure in my table that's right. I don't think I'm counting this right. The point, oh yeah, it is 3, and then the red one, negative 3. That's good. 1, 2, 3, 1, 2, 3, negative 3. And then I can match over there. It's going to be just like that. This is enough points. Once you've got 3 on one side, 3 on the other in your vertex, you're pretty good. I guess I can go one more. It's going to be 4, negative 10, my calculator's telling me. 4 in the X, negative 10 in the Y for the red. So I'll just go to 4, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's nice. That's going to make me really put my... Oops, that's no good. That last little plot's going to make my graph really look nicer. I accidentally put something wrong there. And then I'll try my best to kind of follow this line, making it that curve that I know it deserves to be. La 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 la. I have successfully graphed this, and other than the fact that it's in 2 different colors, which you'd probably get deducted points for on the real regions, this is 2 full points. Great, that's fantastic. Next, what I need to do is check and see, does f of negative 2 equal g of negative 2? Well, you just got to remember, if you just remember that when I have my function notation, that the number inside of the parentheses there means it is your input. I'm checking to see when I have an input. What's input? It's my x values. When I have an input of negative 2 for my f function, which f happens to be the blue function here. I'll circle that in blue. Or I'll say blue is f of x, and I'll say that red is g of x. When I have an input of negative 2 for f of x, it's saying, is f of negative 2 equal to g when I have an input also at negative 2? So again, it's also my input. Now you can either plug negative 2 in there and plug negative 2 in there and show it algebraically. It says to use the graph to explain, so probably if you do that, it's only worth 1 point. Still good points. But if you look at your graph, f of negative 2 means my input means my x of negative 2. I'm going to go to negative 2 in the x. And on my absolute value function, it's got an output of 2, right? I've got the point in blue, negative 2, 2. And then I check my g function also. I go to negative 2 in the x. And that is also at the point in red, negative 2, 2. So they do equal each other, right? At negative 2, they both have the exact same coordinate. And what I can say is, yes, f of negative 2 equals g of negative 2 because the two graphs hit each other. They both intersect at the point when my x is negative 2. Because the graphs intersect when my x value is negative 2. And that's it. You have your beautiful graph. You have your nice explanation here. That is 4 full points. It's a lot of easy points to get from this question.